Section 6.5, Sampling Distribution of the Sample Mean and the Central Limit Theorem. So now you have most of the skills to start statistical inference, but you need one more really big concept. So first it would be helpful to state what statistical inference is in more accurate terms. So statistical inferences, as we had mentioned back in Unit 1, root word here on inference is infer, which means to make educated guesses. And in this case, for statistical inference, we're making accurate decisions or educated guesses about populations, but we're basing that information on sample data. Okay, so statistical inference is where we're going to make accurate decisions about populations from samples. So when it says accurate decision, you want to be able to measure how accurate. And we measure this with probabilities, okay, which is why this whole second unit here is dealing with probabilities. So in both binomial and normal distributions, you needed to know the random variable followed one of those two distributions to be able to use the binomial and normal probability functions on the calculator. So you need to know how the statistic is distributed in order to be able to find the corresponding probabilities. So in other words, you need to know the shape of the distribution of all possible sample means, or whatever statistic you want to make a decision about, but this tends to be the one that we look at when we have quantitative data. So we learned that also back in Chapter 1. Okay, so our parameter and our statistic for this intro-level course when we have quantitative data tend to be the mean of the population and the mean of the sample. So we're looking at the distribution of all possible sample means when a sample size of little n is taken from a population. So how are those possible values of the statistic distributed? This is answered with something called a sampling distribution. Okay, so again, as its name implies, we're going to be looking at a distribution again, so possible values and how likely they are to occur. But these values that occur are the result of taking some sort of sample and computing some summary number from that collected sample data. So a sampling distribution is the probability distribution for all possible values of a statistic computed from samples of size little n from a given population. Now, for our particular course, that statistic is going to tend to be x bar when we have quantitative data, and will be p hat when we have qualitative data. So sample mean when we have quantitative data, and sample proportion when we have qualitative data. So looking at example 6.5.1, sampling distribution. So let's assume that the waiting times during peak hours for a randomly selected commuter have a uniform distribution from 0 to 50 minutes. So this gives us the following random variable for this problem. So we're looking at the waiting time during peak hours for a randomly selected commuter. So again, the format for our random variable in this class for quantitative data is going to be the measurement for a randomly selected individual. So our measurement here was the waiting time during peak hours, and our individual is a commuter. So the probability distribution of this random variable is in the figure below. So again, it's uniform over the interval from 0 to 50. And remember that this total area shaded in the rectangle here must be 1. So if the base of our rectangle here is 50, that means the height here has to be 1 over 50, which is 0.02. Okay, so that's what we can see here for our height across that entire rectangle. Alright, so now let's say that we take a random sample of 10 commuters. So that is little n is 10. And we're going to record the waiting time for each individual. Okay, so we're going to have 10 values of the random variable x. But then from those 10 values of the random variable x, we can compute the one mean waiting time for those 10 commuters. And that's going to give us a new random variable that we can look at. So now x bar here is going to be the mean waiting time during peak hours for 10 randomly selected commuters. Okay, so x bar was our symbol back in chapter 3 for sample mean. So we've got the word mean in here, and we have our sample size of 10. Okay, the random variable x, we're still looking at, again, our variable was the waiting time during peak hours. And our individual was a commuter. So in this case, we have commuters now that we're looking at a sample of 10. Okay, so our wording here is going to be the mean variable, whatever measurement that we did, for n randomly selected individuals. So in particular for this one, we get the mean waiting time during peak hours for 10 randomly selected commuters. So now we're going to use an applet and StatCrunch to simulate collecting data from 10 randomly selected commuters and commuting their mean waiting time.